Hi guys, today let's talk about the derivation process of Amdahl's law. So first, let's start by making some initial assumptions. So the task usually consists of two parts, a sequential part, theta. Sequential part. And a parallel part, pi. The total execution time for a task on a single processor, remember, a single processor, so it's T1. So T1 just simply equals to theta plus pi. Second step. Let's assume the task is executed on n processors, which means the number of processors is n. N processors. The parallel part pi can benefit from the parallelization, while the sequential part still remains the same. So the total execution time on n processors, which is Tn, equals to theta plus pi divided by n. The third step, let's define the alpha. So do you still remember alpha? Alpha is a fraction of the task that is non-parallelizable. So alpha just simply equals to the sequential part divided by the sequential part plus parallel part, which is theta divided by theta plus pi. So we can do some simple operations here. Theta is equals to pi multiplied by alpha divided by 1 minus alpha. So the fourth step, using the above equations, we can rewrite the speed up as S, which is the ratio of execution time on a single processor to the execution time on n processors, which equals to T1 divided by Tn. So we use this one to replace T1 and use this one to replace Tn. We can get theta plus pi and theta plus pi divided by n. And here, we can use one to replace here and also here. So we get pi multiplied by alpha divided by 1 minus alpha plus pi, and here. And here we can see both the divisor and the dividend has a common factor pi. We can simply divide it by pi. Okay, here we get alpha plus 1, and here we get alpha. Now we both multiply by 1 minus alpha, we get this one. Now we simplify this equation. We can get like something like this. So when the n is really large, let's assume it approaches infinity. So 1 minus alpha divided by n would also approach 0. So finally, S equals to the inverse of alpha.